Okay, hello everyone. Today we start modeling our system with faults and disturbances. So as we all know, we start with having x dot in time or x dot discrete time that's denoted as x dot of p, which where p represents either time or k in discrete time systems. So let's first write the model as we all know, which is x dot p equals a x of p plus bu of p. But let us now introduce two more matrices and two more inputs, which are the disturbances and the faults. And let's represent them as ED times the disturbance plus EF times F of t. Whereas ED and EF are only constant matrices. Let us now introduce the output model, which is y of p equals cx of p plus du of p, and that's all we know. Let us now introduce two more points, which are fd of the in times the disturbance as well, plus ff times the fault matrix. And fd and ff are also constant matrices. So now we have two additional inputs, d of t and f of t, or f of p and f of p. These inputs are the disturbances, here disturbances, and these are the faults. Now let us check what type of faults do we actually have. As we all know, here's the basic block diagram of a mechatronic system. Here we have a controller. This controller input W, control signal, which feeds to the actuator. This actuator feeds to the plant. And we can measure the states from the plant using sensors. And here are the outputs. And of course we feed back our outputs to our controller. Now we have three different faults. First is actuator faults, we denote it as FA. Plant faults, we denote it as FP. And sensor faults, we denote it as FS. From here, let us get back to these matrices EF and FF to actually know what affects them. Let us show. For the sensor faults, we can have EF as 0, since the sensor faults do not affect the states directly, but it affects only the output. So EF for the sensor fault should be 0. FF should be equals to identity here, this matrix, affected only by the sensor faults. And we can have Y as an outcome equals Cx plus du plus fd d plus fs, since ff equals I, which is here, I. So we can just remove it. For the actuator faults, we can introduce, if we have only faults in the actuator, we can introduce the EF as the B matrix, which is the input matrix here. So they are equal, since they are affected by the control input here to the actuator. And the faults FF equals D, since they are also affected from the U, from the control input here. Now let us rewrite the state space matrix representation, whereas x dot equals AX plus B times U plus FA plus ED times D, and Y equals CX plus D times U plus FA plus FD times the disturbance matrix. Lastly, for the component faults, we can have EF equals to EP, which is just a matrix. We can model it as we want. And also FF equals FP. So X dot equals AX plus BU plus ED times disturbance plus EP times the faults caused by the plant. And Y equals Cx plus du plus Fd times disturbance plus Fp times the faults as well caused by the plant. Finally, we can augment the matrices as F equals column vector FA, FP, and Fs. Also, we can have EF equals to B, EP, and 0, and FF as D, FP, and I. Now, since we know our control input, which is fed to the actuators, to the plant, and to the sensors. Of course, as we know, we have faults here, FA, FP, and FS. Our goal in fault tolerance and fault control is to generate a residual. Let us have here, oops, let us have a residual generator, residual generator that outputs a signal R. From this signal, we can identify through another block whether we have a fault in the system or not. And of course, here's the output. The residual generator is affected by 4 different parameters. First, the output from the sensors. Second, the control input. Third, so that's 1, that's 2. Third are the disturbances. 4 are the actual faults. So our goal now is to know the faults from this block, where we have 4 different signals that affect it. So our goal now is to decouple the inputs, the outputs, and the disturbances from this in this block to identify the faults that are caused by these 3 blocks. And this will be our topic in next videos. See you next videos.